So thank you for being here, everyone. So today, basically, I have a little bit of a different talk. So I'll not be talking about L2s or EVMs or all of this deep blockchain stuff, but instead I'll be talking about building good front ends for that. So basically, we have build universal Web3 apps with React Native. My name is Thiago Brezinski. I work at Costek. I'm a senior React Native developer. And basically, at Costek, we're trying to work in this niche intersection between Web3 and React Native, and trying to understand why it has been so difficult to build good Web3 mobile applications until now, why it's not the case anymore, and how we can do it with React Native. So first, we need to talk about what are universal apps. And these are apps that basically, using the same code base, you can target multiple platforms. So the beauty of React Native is that using the same code, you can build to iOS, to Android, to web, Windows, macOS, and even visionOS and other different platforms. But the thing to keep in mind here is that it's not a web view. It's not any custom rendering engine. It's just using native components. So JavaScript, in this case, is just orchestrating the native components from the operating system, and you get the whole native look and feel. So this series of tweets got pretty popular around last year, when Matt was basically saying that people didn't even notice that React Native was being used in the PlayStation 4 and PlayStation 5 UI until the community was jailbreaking the PlayStation 5. So this is how you can know that React Native just integrates seamlessly with other native applications, and you can keep the native look and feel and performance. It's also used in the Xbox UI also, because Microsoft is a big player in the React Native space. So if you're not familiar with React Native, this is the basic, most basic code you can get to build with React Native. And if you're familiar with web development, then you can just you can know the analogy here. Basically, the views will be HTML divs, and text are an analog to paragraphs, for example. And this runs in every platform, as I mentioned. So we need to talk about the current dev situation. And basically, if you look all around Web3, you're going to see that most dApps are web-only. And only maybe the top 3 dApps will have the equivalent native mobile experience. So for example, if you look at Blur, it's only web. If you look at SushiSwap, the exchange, it's only web. Also, Hey, the Lens protocol client, only web. But then we have a few good mobile contenders. For example, Orb, another Lens protocol client. Especially now in V2, they're excellent mobile experience. Also Warpcast, which is also a universal app. It's amazing. And Uniswap, we don't even need to talk about it. It's amazing. But why? We need to talk about why it has been this way, why it has been so hard to build good Web3 mobile experiences. And it's mainly because of the popularity of the browser extensions. Because the browser extensions wallets, they basically standardize this way of injecting the Ethereum provider inside the window global. And the window global is a browser web API, right? So when you try to take this out of the browser, it's going to crash, obviously. And then most of the Web3 libraries were built with this in mind. So they're also sometimes hard to port outside of the web. And this leads to a big number of polyfills when you want to bring this to mobile, for example. So let's talk a little bit about polyfills. So a few months ago, if you tried to start a React Native project with Web3 using the famous Web3 libraries, you would probably stumble across these errors and maybe more. These 3 are only a few of the most common ones. And basically, it's missing APIs from the web that are not present in React Native. So for example, let's go a little bit into each of these. So in the first one, we basically don't have the crypto module, which is present in both the browser and Node.js. The second one is ATOB and BTOA. These are base64 encoding and decoding APIs, also not present. And then we have the text encoder MPI, which is also not present in the React Native environment. So let's talk about a little bit of these and why it's not the case anymore. It should be already fixed. So first, the crypto API. So most often, even Web3 dApps, when they need the crypto API, most often they only need a good way to generate random values to use as a seed for the crypto functions and crypto hashes. And this needs to be generated natively because JavaScript doesn't have, can't guarantee enough entropy for random values. So most often dApps will only need this from the crypto API. So if you only need this, you can just install this polyfill called regnative get random values. It's done natively for iOS and Android, uses native APIs from each platform that is already battle tested for years in these operating systems. If I remember correctly, what is used in iOS, it dates, and the API dates from iOS 3, if I'm not mistaken. But then if you happen to need the whole crypto module, then you can just install regnative quick crypto, which is meant to be a complete replacement for the Node.js crypto API. And then when we talk about the other two polyfills, so base64 and text encoder, basically, we have the Hermes team, so this big green H here. Hermes is the JavaScript engine that powers React Native. So for example, on Chrome, we have the JavaScript engine, it's called V8, when it's the same on Node.js. We have a custom one for React Native to better fit React Native needs, for example, startup time, which is more important in a mobile app. And the team at Hermes, basically, they polyfill this natively into the JavaScript engine for us. This is actually very recent, like 1 or 2 months ago. And this should already be present in React Native 0.74, which is the next version that should be coming in the next few weeks. So this also should not be a problem anymore. So at this point, we should be good to write a React Native application for Web3 using Web3 libraries and have very little problems. So let's talk about the next generation of Web3 apps. I strongly believe they will be built with React Native for multiple platforms at once, and it's going to be using those tools. So Expo, React Native Web, React Navigation, VN and WAGMI, and the Wallet Connect Web3 model. So here on the right, we have one example that you can build using React Native, targeting native platforms, for example, this app in the right, and also have the equivalent web experience to the left. So you can see that I can also specialize. For example, on the web, I prefer to have a sidebar instead of tabs, which are not popular on the web. And then I can just, on mobile, I can just use my tabs. Also on the web, as I have more screen real estate, I can put more columns in my list. As on mobile, I only keep one column because it's better. So these are only a few examples of what you can do. You can do whatever you prefer to get the best of each platform. So let's talk about each of these tools here just a little bit in case you're not familiar. So if you're not familiar with the React Native ecosystem, there is Expo. Expo is a framework to help develop universal apps. Think of it like the Next.js of React Native. So they provide you with a lot of curated native modules, for example, maps, camera, images, geolocation, sensors, whatever you can think of. Then they also help you with automated builds, deploy to app stores, and over-the-air updates. Basically, if you're starting a React Native project today, you should probably be going with Expo because they will facilitate several things for you. Then we have React Native Web, which is used by Expo under the hood. And it's a compatibility layer between React DOM, which is React Web, and React Native. Basically, React Native Web will take your React Native code, like views and texts, and translate it to the web APIs, to divs and paragraphs, for example. Much more, of course, but this is just a basic example. Then we have React Navigation, which is the standard navigation library in React Native. React Navigation provides you with these navigation primitives like the tabs, the sidebar, or pushing stacks on top of each page. And this is also using native APIs from each operating system. Then we have VM, which I believe many people here might know. It's very popular in the last year, let's say. It got a lot of rise in downloads. And it's a lightweight interface to Ethereum. So it's an alternative to Web3.js or Ethers.js. And you can communicate with the blockchain, so send and receive data. And the advantages is that it's lightweight and performatic. So for example, in the first 2 lines, we can see that we're querying data from the blockchain, so getting the block number and getting the gas price. And in the last 2, we're asking the wallet to sign a message or send a transaction. So it's easy like that. And then we have WAGMI, which is built by the same team as VM, and it's just a React hooks wrapper on top of VM. So it's basically a React way of using VM. And you get these reusable React hooks. You get caching, you get persistence. It's just a better development experience to interacting with the blockchain. And of course, VM is a dependency of WAGMI. So you basically, usually you're going to be installing both of them. And finally, we have Wallet Connect Web3 model, which I'm certainly everyone here already saw it when interacting with dApps. Probably maybe the most famous model to connect the wallet. And they integrate well with VM and WAGMI that I just showed. And they actually have both a React Native SDK and a web SDK. So in the web, you get this center-end model, and in React Native, in mobile, you get this like bottom sheet, which is more like a mobile look and feel. So I talked about all of these tools, but how we can actually do it to build a universal app. So basically, you need to do these 3 big things, which is setting up a navigation, connecting the wallet, and then interacting with the blockchain. So you may already see where I'm going with this. So to set up the navigation, we're going to be using platform-specific code. So basically, React Native has this platform API that lets you like branch off or run conditionals, run different code for each platform. So in this case, for my navigation, the example I showed you before, for when I'm targeting the web, I want to render a drawer navigator, which is that sidebar. And when if I'm not on the web, I'll be on mobile. Then I want to render the tabs. So the beauty of this is that I'm just replacing the shell, but the screens inside, they're the same. So we're reusing the same code for our screens, and all the data fetching, all the components are going to be the same. So instead of also checking for the web, you could be checking for iOS, Android, specifically if you need. And then after we set up navigation, we need to connect the wallet. So to connect the wallet, we're going to be using platform-specific file extensions. So imagine you have a button that you want to make it look different on each platform. You could also be doing this the same way I just showed you, but there's another way, which is just using these file extensions. So you can have a button.iOS, button.android, button.web, and it's going to be loaded conditionally on each platform. And this is powered by Metro. Metro is the JavaScript bundler for React Native. So a bundler is basically what takes all your project files, how do you say? It analyzes the dependencies and outputs a single JavaScript file in the end for production, right? So Metro is going to see these file extensions and drop the ones that are not needed depending on the environment you're running. So we're not talking about buttons. I want to know how to connect the wallet. So as I said, the Web3 model, Wallet Connect Web3 model, they have both a React Native SDK and a web SDK. So what we can do here is we can create a directory called Web3 model or anything else you want. And then we have 2 index files. So we have a standard index.type.ts and then an index.web. So since the web is more specific, it's gonna take when it's running on the web. And in every other case, it's gonna take the plain index.ts. So if you look at the code here in the right, it's just the same thing. But when we're on the web, we import the web package. And when we're on mobile, we import the mobile package. And the rest is just a standard setup. But how do I use this? So this is the beauty of everything. So you can just import this directory that you just created that has the index-specific files. And the Metro bundler will figure this out for you. So you don't need to do anything. So when this is running on the web, it's going to pick up the index.web file. And when it's running on mobile, it's going to pick up the index normal file. So then you can just import the components as usual and render them. So with this single piece of code, you're going to be using this model on both web and mobile. So after connecting the wallet, we need to get data. So maybe this is the easiest part for you. So we basically have 2 ways of doing this. First is using the Ethereum interfaces, such as VM, as already showed. Then we can use data aggregators, such as Zora, such as Alchemy, or using the SDKs itself. For example, Lens Protocol, in their SDK, you can query posts or users directly through the SDK. So in the example I'm going to show next, I'm using the Alchemy API, where you can just pass an address and get all of NFTs for that address. And then I can just use that to render a list. So when you mix it all together, for example, in this case, I decided to put my Wallet Connect button on the sidebar on web, and on mobile, I decided to put it on the header. When you click it, you get this native look and feel for each platform. So it's using, with the directory we created, it's using the web API on web, and this bottom sheet, the React Native API on React Native. And after you connect your wallet, you can display the data that you just got. So the same example as I showed before, we can specify better for each platform. So in this case, on web, I decided to have 4 columns, and on mobile, I decided to have only 1 column. But you can do this as much as you want, as much as you think you can take advantage of each platform's strengths. So another example is using the Lens Protocol. You could create, for example, a cross-platform Lens Protocol client, where I'm using the SDK to get my profile on testnet. And then, for example, if you move to the homepage, you could be querying the posts and showing these posts in a cross-platform way also. So you have a native app, you have a good web app, and you can just reach a much more broader audience right from the start without too much effort. So if you want to know more about this, these 2 examples are in these QR codes. So in the left, we have the universal NFT list, and on the right, we have the Lens Protocol client. And if you want to know more, we go deeper into this, into the call stack blog. We have these 2 articles explaining why these decisions of why we went with this code and how to do it more specifically, and other cool topics also. If you want to know more about this also, you can find me in the conference or find me on X, Farcaster, or Lens. Just send me a message. Thank you.
Perfect. Thank you so much. We do have some time for questions from the audience, if anyone has any questions. No? OK, then I actually do have one. So from your experience, what do you think is the biggest difference for building Web3 applications versus Web2? And what's the biggest challenge for building for Web3?
Honestly, the thing that is different is basically fetching data, because you're just fetching from the blockchain or from one of these options I showed. But the rest is mostly the same. OK, instead of logging in, you connect your wallet, and then you need to fetch data from different places. But the rest is mostly the same. You still need to do the same performance optimizations. You still need to, you face 90% of the same challenges as a normal front end. Yeah, and that's what we're trying to do here.
Awesome, cool. And what was your motivation for building for Web3?
It's just that because we develop a lot of mobile apps, and when I started on Web3 a few years ago, you just notice that you don't have very good mobile apps, except for the top 3 or top 5 big players for a long time. So yeah, you just notice that there's something missing, and you don't know why. So we're trying to explore this intersection and try to help get better mobile experiences.
Awesome, cool. Thank you.
Thank you.
Please give him a big round of applause again.